My name is Raghunathan and I'm a mathematician. I am here to interview Professor Ramanan. Professor Ramanan is one of the outstanding mathematicians to come out of the TIFR and among the best produced by this country in the second half of the 20th century.
I am Kaushik. I am one of the Kaushiks of Tata Institute. I was in the math school as a student back in 1966, and during my first year there, Ramanan taught us, and from those days we have been friends. He has always treated me and many of us as a friend. In fact, number of dinners I have had in his house must be uncountable, and I greatly value being his friend over these years. He's somebody who is very, very friendly, and so is the family.
TIFR, that is the Tata Institute of Fundamental Research, has been a major research institute in this country and actually is responsible for having put India on the international map of mathematics. And Ramanan, one of the professors there, was among the people responsible for this achievement of TIFR. He is among the finest mathematicians in the country. His area of specialization has been largely algebraic geometry, but he has also done some very significant work in differential geometry. There is the famous result known as existence of universal connections, which was proved by him in collaboration with Professor M.S. Narasimhan. In fact, he is the person who formulated the problem in the first instance, and as often happens in mathematics, the more important factor is to pose the problem rather than the proof. And his later work, much of it in collaboration with Professor Narasimhan, has been in the area of vector bundles on curves with one of his students, A. Ramanathan. Well, he is a very versatile mathematician with deep scholarship in different areas of mathematics, which is a rare thing. You don't find a universal scholarship of his kind any longer in the country. Okay, so where were you born?
I was born in a place called Tiruvannamalai, and it had a hillock, and there is a temple on top, and the god there is called Arunachaleshwarar. Aruna is the charioteer, as you know, charioteer of the sun god, and usually the sun rises there, and then people from Tiruvannamalai enjoyed the sunrise from there. Therefore, it was called Arunachala, and in Tamil it became Tiruvannamalai. My mother's brother used to live there at that time. So she went there, as was the custom, for childbirth. My mother had gone there. And that is where I was born. And it is said that my mother's sister's sister-in-law was the one who found Ramana Maharshi on the hill. And therefore I was named, they are all great devotees, even today, of Ramana Maharshi. And so I was named after Ramanan. I had an alternate name, it was called Arunachalam.
And where was your father at that time?
My father was in Matunga in Bombay. He was working for a British company here. He was the first in the family, in my father's family, to have gone out of the traditional Vedic scholarship. And he essentially said that he essentially escaped from the routine, and with one trunk full of things, he just, without knowing anybody, he came to Dadar and got down and didn't know where to go, and somebody took pity on him. Some Matunga, Dadar, that area was full of South Indians, and some Brahmins saw him and then said, "Where are you from?" Then he explained, and he was taken to his house, and that is how he survived. And he had, by the time I was born, so he had already acquired some amount so that we could at least call ourselves middle class at that time. So I was the second son. My brother was also there at that time.
So how long was your family in Bombay? You eventually moved to Madras, Chennai, right?
Yeah, I was in Bombay. I grew up in Motunga, where most South Indians lived at that time. And I went to school, primary school in Motunga. And then when I was 7 or 8, around that time, in my father's office, he thought that an Anglo-Indian superseded him in promotion, and so he got annoyed, and so he decided that he would leave that job, and he wanted to do. He had collected. He had already accumulated some amount, and so he decided that he will go into business. So he tried a few places here, and he wanted to do printing business. So he went to one Talwar printers and one Kothari printing press. He tried a few places to buy, and then it didn't work out. So he decided he will go back to Chennai. I was 8 at that time. So we moved to Chennai, and he started a business there. And the business was very successful for some time. And then afterwards, in the 50s, there was a depression. And there he lost all the money and so on. And so our family had up and down, you know.
Where were you living? In Chennai, where were you living?
We were living first, as soon as we moved, we were in West Mambalam. Then after the business succeeded, we moved to T Nagar, and that is where I was living till my SSC. Then, as I said, the business took a knock, and so we had to move down. And actually, before that, he had even acquired a bungalow in Burkitt Road in T Nagar. So we were living reasonably well at that time. And then when the business failed, so we had a very horrible time. Financially, there was a time when we didn't know even when the next meal, where will it come from? That was the situation. Pawning jewels and things like this, and so on and so forth. Somehow we survived. And in fact, I must also say, when I got into mathematics honours, they offered me a scholarship because I had done very well in my intermediate and SSC and so on. But my father said, no, we don't need scholarship. After 1 or 2 years, we couldn't continue. Therefore, I had to go back and ask them, please give me the scholarship which you offered 2 years ago. So somehow I survived at that time. So
which school did you go to?
I was going to Ramakrishna Mission High School, which is in
Panagal Park.
Near Panagal Park.
Okay.
Yeah.
In fact, on the Panagal Park.
I used to walk every day to the work. Initially, I was in PSI school because I was in Mylapore, just 1 year. And then when we moved, I also moved to Ramakrishna Mission School.
PSI school had classes only from 6th standard, right?
Yes. Yes, sir. Actually, that was a big problem. Very close to my uncle's place, there was PS Secondary School. That is where I was supposed to go. But that was the year when the PSI school stopped the 5th standard. and started from first form, which was 6th standard. And I had to join 5th standard. So my father had to use some contact here with the PSI school, where he had studied in his in his SSC. So he knew the principal. So the principal said, if you can say it is private tuition and so on, you don't have to show the, but then we will have an exam. And if he passes the exam, we will directly take him to the first form. So I somehow passed the exam, and then I went to first form there. That is how I finished 1 year earlier. So my official age is 1 year more than my actual age.
So, which year did you pass out of Ramakrishna Mission School?
It was 1951.
And then
I was 14.
Okay, and then you went on to do intermediate.
Then I went to Vivekananda
Thanks to
College.
your age being given.
The age was 15, so I could go into the university. So I went to being in Ramakrishna School. I went to Vivekananda College, and at that time I was a Ramakrishna Bhakt also. Ramakrishna Mat I used to go and meditate and stuff.
So you used to commute from Mambalam from T Nagar to Melapur to Vivekananda College.
Yes, Vivekananda College. Yes, taking the bus.
Bus service was not great. Bus service was not great in those days.
It was not great. But that Chennai Motor Service or something was from the station, Mabalam station. So I would walk to the station and take it from the initial place. So it was not so difficult.
Oh, it was not run by state government?
No, they were not. Private. They were all private in those days.
How did you like your schools?
I liked Ramakrishna Mission School very much. And they were not also in the Vivekananda College. Particularly after I joined Mathematics Honours, they were very good teachers, meaning they were not aware of contemporary mathematics. But they had this enthusiasm, and particularly one of them had a lot of geometric insight, 2-dimensional, 3-dimensional, and so on and so forth. And that was inculcated to me. And later, when I worked on higher dimensional, this geometric intuition really helped.
Did you have any teachers in school who were inspiring? When did you actually get hooked on mathematics?
At school, I must say, there is a small episode. There was in second form, 7th standard, there was a non-detailed textbook in Tamil, and it was called Three Great Men of India, Moondru Indiya Periyargal. And these three were Professor Chandra Roy, Jagdish Chandra Bose, and Srinivas Ramanujan. And Srinivas Ramanujan's letter to Hardy, and it was all translated in that textbook. And I'm not saying that is the only reason, but in that, Ramanujan had said, if you add 1 plus 2 plus 3, etc., in some sense it will be minus 1 over 12. And if I said it, you will think I should be in a lunatic asylum. And of course the teacher who taught it didn't know what it meant. But I went to a cousin of mine who was supposed to have known some mathematics. So I asked him what it is. And then he said, it doesn't make sense. If you add, it will only increase. How can it go to minus 1 over 12? The fellow who wrote it, the author, doesn't know what he is talking about. But somehow had the good sense to feel that this cousin doesn't know, that someday I will understand what this meant. And it took 10 years, I guess, before I could understand the Riemann-Zeta function and understand what it meant. So that's some of these little things make. I must say, even today, the interest of bright students in mathematics is partly due to this idealization of Srinivas Ramanujan.
When you were young, did people say he's good at mathematics?
Yeah, I must also say there was one of the examinations. Usually, I used to get 90 or 100, in mathematics, and in one of those, I think the fourth form or something, I didn't do well in the mathematics exam. But then when the result came, the class teacher, who's the head of the class, and he was reading out the mark list, and then said, Ramanan, 30 upon 100, it cannot be correct, he said, because how can he get 30? Then I was almost crying. So he sent it back to check it was correct. And it was actually 60 upon 100. So it was, while it was not very good, it was not a disaster as I thought. And then he said, as I said, it is not 30, it is 60. They did not enter it properly. It was for 50, so they had to double it. So they didn't do it in my case.
What about other subjects? Did you like the other subjects as well, or was it mathematics alone that had?
Yes, I was very good at Sanskrit because of the background, of course. And what shall I say?
Science in general?
Science in general, it was okay, but science was good. English, Sanskrit, and mathematics. I would say these are three subjects in which I was doing very well.
So you had no particular fascination for other science subjects, physics or chemistry?
Not much, no.
And then intermediate, of course, you must have done the physics, chemistry, mathematics.
Yes.
Right.
First group is what it was called.
What was your mark in SSC? What's it total you scored in MSc? Do you remember?
Yes, that was very good, actually. The mathematics, the SSC was very good, but intermediate was not that good. Because in intermediate, towards the end of the thing, in January or something, I got some disease, and so couldn't go to college for some time, and so on. So I missed out. I did reasonably well, but not as well as I used to.
In maths, I suppose you scored 150 on 150?
No, 130 or something. I said I will go to mathematics honours, which finished the 4-year course of 2 years of BA and 2 years of masters. It does in 3 years. So I was quite happy, and fortunately my father did not insist. He was saying that you should take to engineering, you have done so well. In those days, if you did well, you went to engineering. But I said I want to do maths. And one of the reasons was a senior, 1 year senior, Sridharan, he was interested in mathematics. And he said, if you are interested in mathematics, why don't you do honours, B.A Honours in mathematics? And I wanted anyway to do it, so I joined the Vivekananda College and did excellently in mathematics.
So how did
I was second in the university. So, and also the first year there is what's called a preliminary, which is in English. And I was first in the university in English. I didn't know. In those days, it didn't matter. You passed that examination in order to continue in the next year. But that year, Vivekananda College did excellently. Because you see, when you say, in those days, even Trivandrum was part of the Madras presidency, and therefore when you got high rank, it is not only in Chennai, it is all over Trichy, this, that, and so on, including Trivandrum.
Who stood first?
One Krishnan from Vivekananda College. He took to banking afterwards.
In Vivekananda College, you found teachers to be very good. Do you have any interesting anecdotes about any of them?
Well, Raghav Shastri was one of those who taught this, and as I said, he had good geometric intuition, although it is three-dimensional. Well, on the other hand, he did not know even what a group was. And there was some intercollegiate lectures. One Subramaniam, who kept, with the contemporary mathematics, he was trying to understand and so on. So there were intercollegiate lectures in those days, and he was giving an intercollegiate lecture. And then he was trying to explain what was a normal subgroup. And then he wrote xh is equal to hx. Then you call it for every x, then you call it a normal subgroup. And then to the for these intercollegiate lectures, Raghav Shastri had also come. And he was sitting like this and said, "Is it not called abelian?" So that was the status of knowledge at that time.
It's amusing because Subramaniam also gave a bunch of lectures on group theory to our batch. That was 4 years later. I didn't understand anything that was going on, but it was clear he was one man who knew some contemporary mathematics.
Contemporary mathematics, yes.
As a contrast to all others. And then what made you go to TIFR?
Yeah, again, I must say, Sridharan had joined the TIFR, and I met him. And except that, when I passed my exam, B.A Honours, it was in 1956. That was the only year when there was no recruitment in TIFR, because Chandrasekharan had gone to Institute for Advanced Study, and K.G. Ramanathan had gone to Göttingen University in Germany. And so there was nobody to actually select. And therefore, there was no interview that year. And my family, as I said, was in a very bad way. So I had to earn. So I became a clerk, upper division clerk in the railways. Before that, I also tried to become a clerk in the postal department. And I did very badly in the interview because I didn't even know what districts were there in Tamil Nadu and so on. So rightly they rejected me. In the interview for railways, there was one Srinivasan, and he had passed B.A Honours in mathematics. So I think in order to impress others, he asked me some questions on function theory, which had nothing to do with railways. And I answered naturally, because they were very, very basic questions. And so I answered them well. So I knew that I would be selected, because there were no other questions which was related to railways or travel or whatever. And again, a quirk of fate, I was sent to Tirchi for training for 6 months. There was also a test, Presi test. That is, how when you know something, in order to present it to the officer, you have to contract it. So I was given a test there, also for Presi, which I did very well. And in fact, one Sundar Shastri, who did who looked at this result, he said, "You have a really talent for Presi writing." So for 6 months I didn't have to work. Then for a few months I had to actually do clerical work, and then I applied to the Tata Institute. And there, the lucky circumstance, So when I was in Trichy, I had to take my food in hotels, restaurants and so on. And I had some stomach problems connected with it. My father had retired to our village, which is Thirukazhundram in the Chakilpet district. So I wrote to them, I have this problem, why don't you come to Trichy? Instead of having living separately, you can come here. And so they came there. And one day, my mother, so she said, in the Hindu I saw today, you used to say TIFR, TIFR all the time. Now there is an advertisement for research assistants or something like that, she said, research students or something like that. Then I looked at it and it was, otherwise I would have missed it. So I applied, and one of my colleagues there, one of the fellow clerks, had also done mathematics honors, and he had his notes, so I could recoup. So I went there, performed reasonably well, and Chandrasekharan and Ramanathan had both come. Ramanathan had not come, Chandrasekharan had come, but there is a great mathematician called Schwartz, and Schwartz was on the interview committee. And there was one Singbal who was a senior student, and he was also there. And the interview went very well. And they came back and they said, you have been selected. And then join in July or something. So I wanted to join, and the officer said, you cannot go without giving sufficient notice, so you can go only in August. So I wrote to them requesting whether I can join in August. Otherwise, if I had gone immediately, they could not have done anything, but they would have taken, I would not have got 1 month's salary. So it was 150 rupees at that time. So, so I requested them, and I got a return telegram the next day saying that you can join. Permission to join August granted.
Your batch in TIFR, how many were you? Did you have fellow students at TIFR?
How big was your batch?
It was very big. It was about 11 people, except that in the Tata Institute, there were not anybody who could mentor students. They took the students, and Baba said, let them learn. There is no, let them learn and keep reading and so on, giving lecturing and so on, and PhD will come automatically. Without, this was making a virtue of necessity, because there was nobody who could mentor. So this is what Homi Baba said. And Chandrasekharan, there were two people, Chandrasekharan and K.G. Ramanathan. And Chandrasekharan was mostly interested in Riemann zeta function and some Fourier series and so on. And K.G. Ramanathan in algebraic number theory. So if you are not interested in either of this, analysis or number theory, there is nobody to mentor. But Chandrasekharan had the unique ability to get good foreign lecturers, mostly students of Schwartz, Cartan and so on in France. They came and lectured for 1 or 2 months. In my case, the first year, I didn't even know groups, or definition of groups when I came here. And it was in August. And in January, Bhrua was giving a lecture on Lie groups and direct integral of Hilbert spaces. Okay? And later, several years later, Narasimhan said, you might have done research and written nice papers and so on, but the one that impresses me most was that you could write up the notes. Then I told him, I didn't know integration.
You didn't know?
I didn't know integrating functions with values in C and R. So I understood direct integral of Hilbert spaces because it has values in Hilbert space. So you first understand that and then assume Hilbert space is R or C. So you understand, measure the. So he laughed.
Yeah, of course. I know the notes of Burha's lectures, and I must say it's very impressive that
thank you.
that you could do it in your first year. It's remarkable. And how your fellow students? I mean, was MS Narasimhan and Seshadri there when you joined?
No, they were both. They had both been deputed to France. That is why there was nobody who, except Singbal. Singbal knew.
Singbal also went to France.
Huh?
Singbal also went to France before.
Yes, that's true. Singbal also went to France.
Did he go a little later?
He went a little later.
After you joined, okay.
Yeah, he went a little later.
Yes. And so your seniors, what about Sridhar and Gopalakrishnan?
Sridhar and Gopalakrishnan, they were interested in algebra. They were, and they went also after 1 year. They went away to Sridhar and Varadarajan. They went to Columbia.
Gopalakrishnan was there, right?
Gopalakrishnan was there, yes. But I must say, the first day when Burha came, I knew that he was going to lecture on Lie groups. So I had taken Karthon. I asked one of the seniors, one Venugopal Rao, and he told me, I took Chevalier's books, Chevalier's Lie groups, trying to read it, because that is what Sridharan had suggested. And Venugopal Rao said, no, you should not read this. You should go to the masters. You should read Elie Carton. So I went to the library. It was well equipped. So I took Elie Carton's thesis and brought it, and I was trying to read it. And I must say also it was in French, and I learned French and Lie groups together at the same time, thanks to Sridharan's advice. And Burha came to my table and found Carton's thesis. And he was aghast. You are trying to read Carton's thesis. And he said, no, that is not the way to learn Lie groups. You should read Sophus Lie Seminar. Seminaire Sophus Lie. You don't have it in your library? So I went and checked, it was there. So I took it and began. And I mentioned it particularly because it is very important to know how to read, what to read at that level.
Yeah.
And that was not available in India.
I tried reading Chevalier and impossible book.
It was not available anywhere in India. And even afterwards, it was available only in Tata Institute and Indian Statistical Institute.
Which book?
No, I'm saying not that book. I am saying this advice of what to read was available only in select places. Maybe Punjab University in Chandigarh.
So you were a bunch of 11 or 12 students
11
together.
Students, yes.
So how was that experience? I mean,
it was very
the place was not like your college.
Yeah, it was very good. It was a very instructive period because you could talk to other people who were also trying to learn, and it was even now I treasure what the time I went through. Yes.
Your batch had Raghavan Narasimhan and Ramanujam.
C.P. Ramanujam. And there are others, Muralidhar Rao, who later became a probabilist. And there were others. There were also some senior people, as I said, Singbal, who didn't do in research as well as expected, but At that time, it was helpful.
So, what was it like? I mean, so you came from somewhat different backgrounds, the students.
Yes.
And Raghavan, Narasimhan and Ramanujan, for instance, were way ahead of the other students in the sense that they had learnt a lot at college already.
Yes, yes.
So,
because of Racine, Father Racine, Father Racine had mentored many people there in Loyola College. And in those days, bright students took to Loyola College or Vivekananda College. So I went to Loyola College, and I didn't go to Loyola College because if you join Loyola College, you have to wear trousers. Whereas in the Vivekananda College, you could go with your dhoti. And that was one of the reasons. I'm not saying that is the only reason, but...
Did you get to know Racine when you were in college?
A little later, after I had joined Honours, Mathematics Honours. And he was very nice to me.
Did he give some intercollegiate lectures?
No. I met him a couple of times going to Loyola College, since I had heard so much about him. So he was very nice to me. And he said, I've heard very good things about you and so on and so forth. I had not done anything much, you see, but still, yeah.
So how was this? I mean, how was your interaction with these people? I mean, so especially Narasimhan and Ramanujan, who had a much stronger background.
And particularly, I learned particularly good things about, I even today remember, functional analysis from Ramanujan, C.P. Ramanujan.
When I joined, I found that you were pretty close to Raghavan Narasimhan. So when did that friendship develop? The very first year or of your...
Yes, from the first year. He was very nice to me till he left. In fact, he thought that when he left, he said, things are not so good here anymore. So would you like to come? In fact, I was in Oxford when he decided to leave. And then he wrote to Atiyah saying, if you keep him for some more time, we can go to the United States from there or something like this. So Atiyah asked me, and then I said, no, I'm going back. And he would also discuss mathematics, even his initial work on Riemann surfaces and so on. I learned quite a bit from him, but more from C.P. Ramanujan. The first few years in the Tata Institute, it was a real great joy. Every time you could talk to, brilliant people were coming, and we could talk to them and so on and so forth. And then it's not only mathematics. For example, when Narasimhan came back, and Seshadri came back from France, I talked to Narasimhan. I learned a lot.
Narasimhan came back in 1960, right, from France. So the first 3 years, you really did not have much contact with him.
No.
Okay, it is only in 60 when he came back.
I had just seen him when I came for the interview. He was there. And when I joined, he was not there.
And you said he had a non-mathematical influence also on you.
Yes, I treasure the time that I spent in the hostel, because there were so many influences, For example, Narasimhan gave me the interest in Tamil literature, which I didn't have at that time. I had only used to read Kalki's novels and so on earlier. But he introduced me to what is called Manikodi group. And so that is not the only thing. For example, Venkateswar Rao, who came much later, he introduced me to Marxism and this and so on and so forth, which I learned directly from the masters. The Tata Institute hostel was a great place for me. I still treasure it.
You were saying about Narasimhan and Manikodi and so on. But this was obviously 1960 after he came back, because I was around at the time. So I also imbibed some of that thanks to Narasimhan. So you were interested in Tamil literature of that kind. I mean, of modern Tamil literature was limited to Kalki before you met Narasimhan and talked to him.
Correct.
Same thing is true of me, but anyway.
Then I began reading Jayakanthan, this, that, and so on. And even afterwards, Narasimhan kept his interest in Tamil literature for a very long time, till almost his death. As I said, there are various inputs which we got, and it was at a high level, and I enjoyed it a lot.
But how about mathematics input? Mathematical inputs, apart from...
Mathematical inputs,
for example,
I got from, let us say, Pavaman Murthy, Simha. Not too much, I would say. I got mathematical inputs, much more mathematical input from, of course, from Narasimhan and Seshadri. Seshadri, as C.P. Ramanujan would say, Seshadri, if you give you a problem, he will make it, in Tamil he said, Akkuver Aniver, which means nuts and bolts. He will completely dismantle and then put them together. So, apart from the seniors, I of course, there was a lot of input from students. When you teach them, they react, and then you got from them.
How about differential geometry? Did it?
Differential geometry, it was, I would say, Koszul visited, and I would call what he taught me. Actually, Koszul was, in the nature, I liked Koszul's way of addressing things. Then Bruas, which was my first year. I loved Koszul's method.
Maybe that is...
And that is why later I wrote a book which was based on Koszul's methods.
No, maybe that has more to do with your liking Koszul more than liking Brua. Is probably because you had become more sophisticated by the time Koszul came.
It is possible. But it was more algebraic. I would call it, in fact, somebody told me that my book on global calculus is algebraic differential geometry.
Who else were visiting professors at the same time as Brua? There were some others that year, right? Along with Brua, there were others.
Yes. Malgrange.
Malgrange same year as Brua.
Malgrange was the first year. 4 people came, Doering and Pitt. H.R. Pitt, yes.
Yes.
Brua.
Malgrange, you said.
Malgrange, Pitt and Doering.
Did you attend any of the other courses apart from Bruas?
Malgrange, yes. More or less it was understood that we will attend all courses. So, Doering I stopped going soon. But Pitt, because that was supposed to be measure theory. So, but I didn't enjoy it. Malgrange was good. Malgrange, and that was very good in the sense that you also understood manifolds and things like that, how analysis has become global.
So the first 3 years, did you already get into problems to work on?
Not really, in a sense. When Sridharan came back.
That was also in 1960.
from Columbia.
Yeah, that was also 1960 or?
Around that time. So he interested me in algebra, pure algebra. And I did some work with him. Couple of papers I wrote. Those were the initial papers which I wrote. But then I didn't enjoy pure algebra all that much. But by the time Narasimhan came, Narasimhan gave a course, and in which I think I was also, and Simha were...
on deformations?
No, on Riemann surfaces and so.
Riemann surfaces.
So it was, so slowly I got into Narasimhan's group, and I did universal connections with him, thanks to my acquaintance with that kind of differential geometry from Koszul, who had come earlier than Narasimhan. And in retrospect, those two papers were enough to get a PhD, because it was...
Algebra papers?
No, differential geometry papers.
2 papers, you said?
2 papers.
One on... 2 papers on universal connections.
Universal connections for compact Lie groups first, and then for general Lie groups next. And however, after all, Narasimhan also had just graduated, got his doctorate. So he didn't know what was sufficient, what was not sufficient. And then after some time, I actually asked him, "Sir, I have been here for so many years, so is there any problem you suggest for a PhD?" I asked him. And then he said some problem of which a Japanese mathematician, Issei, had asked. "Why don't you look at it, since you are familiar with homogeneous spaces?" Which I was, because Borel had come and then I had learned homogeneous spaces. And I solved the problem reasonably. So that was that. And also at that time, Narasimhan and Seshadri were doing thing at that time very of great importance, which was Mumford, which had been organized by Mumford, to do with Moduli of vector bundles. And my method, which I had used for homogeneous spaces, could be done to simplify Narasimhan's thing enormously. Narasimhan and Seshadri's thing. And so he said, I should have got your degree long ago. I'm sorry, but right now you get it. But in the meanwhile, there was a rule in the regulation in the university that when you submit it, only 3 years later you can actually get a degree. So, so even then I had to wait for some more time. But in the meanwhile, Atiyah had seen my paper and he gave me a postdoctoral position in Oxford, even though I didn't even have a doctorate. So in my visit, I learned a lot of mathematics in various subjects, but I didn't do very interesting mathematics research-wise at that time.
So this universal connections, if I am not mistaken, you had posed the problem.
I posed the problem and gave a lot of input into it also.
No, eventually it came as a joint paper.
As a student who doesn't know how to go about a problem, right? So he would ask me, did you check it for SL2? Or no, SU2. He will ask, did you check it for SU2? Then I go ahead and check and so on and so forth. Then said, this is what I did and so on. Did you check it for the trivial bundle? And one doesn't know, you can pose the problem in full, but you solve the problem in particular cases and see if that can apply and so on. Then after, from local to global completely he did, because he was aware of some Nash covering So we used the Nash covering and then we did it. The whole thing was done in 8 days. After I posed the problem, because I was actually playing tennis. He didn't play tennis, but he asked me, "You have been thinking about so many things. Is there any problem you are thinking now?" Then I told him the problem. And then he waited, and then afterwards, when I finished my turn, I came there and then said, "Why don't you look at that problem?" Then he said, "I really don't know how to go about it." Then he said, "Why don't you look at SU2?" and so on. So that is how you learnt, as I said, first from Bruha, what to read, how to go about studying. This is how to go about research.
But you said you had already written 2 papers with Sridharan. What were those papers about?
It was about polynomial rings and modules over them.
Mm-hmm. By the way, the news that Seshadri had solved the two-variable problem came to Bombay before Seshadri came back?
Yes.
You people knew about it?
Yes, we knew about it. And that made a tremendous influence on all of us. We used to even discuss, "Sir, if we can do it, we can also do it, sir," kind of thing, And it is not a problem. Pose somewhere, do as Vijay Raghavan once said. Go to some Japanese journal, they would have asked you some question, you can solve this and so on. It was not like that. This is something which Sher had proposed and so on. And we all thought, we all got enthused so much. And when he came back, he was one of the heroes for us.
You also knew of Kotak and Narasimhan.
Kotak and Narasimhan, yes.
But that didn't seem to have generated the same kind of excitement.
Because at that time I didn't know much about elliptic operators and things like this. So
but someone like Raghavan Narasimhan could get interested in that.
Yes, Raghavan Narasimhan had a great influence also. Particularly when I saw Henri Cartan discussing things with Narasimhan. See, he is an idol and he is a student who joined with us and he is discussing things with him almost like an equal. It was,
I was also told that Grauert was there at that conference. And
no, he came later.
1960.
I don't remember, yeah.
The contribution to function
Grauert
theory.
Came, I don't know. I don't remember.
This was of course hearsay for me because I joined after this international colloquium to which Cartan had come. This was 1960 January is when the...
60, right?
60 January.
Yeah.
I joined in 60 August.
Correct.
So naturally it's only hearsay that when Grauert had also come and that he went about being very aloof and very snobbish kind of thing till he saw the program of the thing and Narasimhan's announcement that he had embedded. After that, he became a different person.
Yes.
At least to Narasimhan is what I've heard.
Yes.
And
also I was influenced by Raghunathan.
Okay.
Particularly, in certain aspects, I would say.
No, when I joined the Tata Institute, there, of course, everybody was talking about Raghavan Narasimhan and C.P. Ramanan and so on. And then, of course, what I heard about them looked very good, but it also made me a little nervous whether, with such guys around, whether one will be able to measure up to what they're doing. And then I found that Raghavan Narasimhan was treating you as an equal.
Yes, he was.
And that made a big dent in me. Okay, if this guy who had no more preparation than I can get into the good books of Narasimhan, I can also do it. So you are some kind of role model for me.
We were sharing a room in the hostel for a few years.
In Narasimhan Seshadri's work, I remember very well one thing, that you gave a simple proof for the fact that the unitary bundles are stable. I mean, we're looking at the exterior power,
correct.
That kind of thing. You didn't publish it as a separate paper, no?
No,
No.
but it was,
I don't think that
it
proof
was
is...
in my thesis, but it was not published.
The proof does not appear in their paper either.
No, not in that paper.
It doesn't appear
But it
in
was in the
in your thesis, you said.
in the thesis.
Okay.
You see, without this, for homogeneous word bundles, it had been published.
Okay, okay.
It was published. Then afterwards, I saw that the same thing can be used to
I think
simplify this.
you saw it even when the...
And this was done. This was the only thing I mathematically did research-wise in Oxford, while I was in Oxford. Then I wrote it to Mumford, and I said, there is a small thing which I noticed, and so on and so forth. And Mumford wrote a very encouraging letter, saying it is not a small thing. You have done, actually you have trivialized some part of it, and so on and so forth, which I didn't even tell Narasimhan Seshadri, because he used the word trivialized.
But I don't know how... I vividly remember you are telling the proof or somebody telling me the proof. Because to this day I remember the proof, of course. So that's it. Using the fact that you get a decomposable tensor.
Decomposable tensor.
Object in the exterior power.
That was
the main remark.
That's the main remark. That was good because we had learnt exterior algebra, linear algebra, etc., in the Bourbaki way.
So, when did you shift to working on vector bundles? At some point you shifted to...
Yeah, completely, yes.
You put aside all your differential geometry before.
Yes, yes.
Though there is one piece of thing which really relates to differential geometry, which is about the Weizenbach formula.
Weizenbach, yes.
You had some interesting comments on that.
Yes, which appeared in my... finally appeared in my book, Global Calculus.
But your remarks were attributed to Seshadri by...
Actually, I improved it, and for Narasimhan, in Trieste there was a conference for his birthday. I was invited, so I talked about that, including the improvement. Then, when I finished and came, Narasimhan said, and now I understand how you have improved it, and so on. So Weizenbach was a formula which you used to prove some vanishing. But what I did was used by Weizenbach and proved some vanishing straight away, and then applied that vanishing to special cases. See, originally when we discussed and we decided, we had the Weizenbach formula, and this formula was used for various things. Instead, in the book, what I did was I used Weizenbach to prove a general vanishing, and then used it and corollary this, and so on. So,
does the Kodaira vanishing?
Does
the Kodaira vanishing theorem come out of that?
Various, yes.
So that Weizenbach formula was actually attributed to Seshadri by Roger Howe, right? At some point.
Yes. And also,
you had not, at that time you had not published it. You had only, your book of course had not appeared.
No.
But it's only in a
book
letter to
appeared
Athiya.
much later.
Letter to Athiya or something you had mentioned.
That is to do with Capelli's identity.
Capelli's identity, not Weizenbach.
Capelli's identity, Narasimhan had nothing to do with it. It was in Hopp's book or what?
I think Hermann Weyl.
Hermann Weyl.
Classical groups.
Hermann Weyl's book. And Athiya said, I didn't understand what is going on. Then I understood it in terms of the universal Euclidean algebra and its center and so on and so forth. And I gave a simple proof and how to apply it. And I wrote to Athiya, and Athiya was very impressed, of course. But as you say, in a book, it was attributed to Seshadri.
By
Roger Howe, right?
Roger Howe.
Roger Howe.
It was only a letter to Athiya.
It was a letter to Athiya.
No.
It was not even published.
But somehow, Raja knew of that. Maybe from Athiya, but...
And Narasimhan, in my 70th birthday or 80th birthday or something, he spoke rather highly of my influence on him also. And afterwards he came and said, I should have talked about Capelli's identity, I didn't.
And after I joined, of course, still the activities were really feverish. I mean, all the time there was seminar going on. We were trying to learn things which were absolutely current and so on. I remember the Athiya Singer index theorem seminar. That's one. The other is we also had a seminar on growth and decay on rock. All these things happened in 62, 63, around that time.
Yes.
Maybe I don't know. So soon after growth and decay paper, the Borel-Serre paper on growth and decay proof of Riemann rock appeared. We had a...
Yes.
I don't know.
Actually, Narasimhan did not react to that very positively, the growth and decay work. It was I and Ramanathan, my student. We liked it very much. Growth and decay version of algebraic geometry, geometry algebraic. It is called. Anyway, his way of looking at
SGA in general. SGA you're talking about.
SGA, yes.
Yeah.
So we studied SGA, and Narasimhan was afterwards, of course, became
great fan.
a great fan, yes.
No, but Narasimhan once told me he studied algebraic geometry from the Didone growth and decay blue book. He and Sheshadri.
That's SGA.
No, EG.
Narasimhan was always open, open to new things. And whatever you say, he will take the positive thing from this. I was amazed when he went to Princeton and worked on the non-compact Lie groups with Okamoto. I was in Harvard at the time, and he was in Princeton. And he didn't know. I knew because of Bruha about the work of Harishchandra on non-compact Lie groups. And he went there, he didn't know much, but he learnt it and contributed. That is something remarkable about him. I am a great admirer.
Yeah. I mean, he has this knack of getting into an area which is totally alien to him and still quickly absorb whatever is necessary and
yes,
prove great theorems.
Correct. He will say, you should do things from the top. And then afterwards, of course, it's not as if he's ignorant. Afterwards, he will have a seminar so that he can understand the basics.
He didn't do it for his work on Harishchandra stuff. I mean, for the realization of discrete series. The realization of discrete series, the work he didn't have a seminar on that, but he got Pathasarthi interested, and that was his thesis after all.
That was his thesis.
Okay, so when you more or less after 64, 65, whatever, you more or less went into algebraic geometry.
Yes, went algebraic.
Vector bundles essentially.
Yes.
And
except occasionally with A. Ramanathan I did something, and with Indraneel I did something. I did something with Kapil. This work with Ramanathan.
Yeah.
I must have got something working from the top, from which Narasimhan used to talk about, because I was not interested in characteristic P mostly, because as I said, my intuition was mostly geometric and not very algebraic. So I was not terribly interested in characteristic P stuff. But then Mehta and Ramanathan wrote this and didn't get the main thing. I said, you should look at it again. So I told Ramanathan, we should do it this way and so on. And then Ramanathan said, within 2 days, you began talking about it as if you knew the whole structure. So I'm very impressed, he said. So this must have been from Narasimhan's influence. Otherwise, normally, I used to, from ground upwards. I would like to know the background, this, that, and so on before working. This was one of the rare occasions where, without knowing the basics, I started there. Then I thought they had missed something, so I supplied it, and the whole thing was done. Normality of Schubert. You do it in characteristic P and it follows in characteristic 0.
Who were the mathematicians who influenced you?
I was influenced by Bott, Borel, Hirzebruch. You will be surprised, Adams. Originally I wanted to do topology. And Chandrasekharan, KC, he wanted to help me somehow at that time, early days. So he said, he wrote to Adams and said, here is a fellow, a student who is interested in your work and so on. So can you take him? And Adams didn't even reply. So I gave up topology. And then afterwards, whether he wrote to Atiyah or Atiyah himself asked, I don't know. I went to Oxford as a postdoc. That is, I must say, I owe much to Chandrasekharan. Because in the days when people thought that you're a very good learner and so on, but your research is not going on because there is no mentor. You don't know what problems to work on. In that situation, somehow he wanted to help me. One of them was he wanted to send me to Harishchandra. Sridharan was still there. And I asked Sridharan. Sridharan said, Harishchandra is a great mathematician, but he is not a good mentor for students. He has had no PhD student. So I will not recommend you to come here. That was very nice. So I told Chandrasekharan, I am not interested in going there.
Who are the other people who influenced you mathematically?
Mathematically,
you had of course mentioned papers, but apart from papers, through personal contact.
In person, Mumford to a large extent. Moriyama from Japan. He was very nice personally. I didn't do any work with him, but I learned quite a bit from him.
Did you have a hero?
I can't think of any specific person. I could say Bott, Raoul Bott. He was one of the nicest mathematicians I have met. I even stayed in their house for a week when I was invited to Harvard to give some lectures. He said, why do you look for a hotel? Come and stay with me. So I went and stayed with him. So, and Borel. Borel was very much interested in Carnatic music. I don't know how much he learnt, but he enjoyed. And he would ask many questions about how the music is planned and so on. Concert is planned and things like that.
How about your own music? How about your own musical
interest?
Where did it start?
Yeah, I have been interested in Carnatic music from very young age because my mother used to sing. One thing I remember is when I was 7 or 8, I was in the bathroom and began singing Bruhi Mukundyati, a MS Vivekananda song. And apparently it was it was done well. And my mother said, excellent, excellent. And then she tried to make me learn from the same teacher who was teaching her at that time on Krishna Bhagavatar. And but I told him, no, music should be learnt only by girls, not boys at that time. I very well remember. She was shocked. And he said, if you don't want to learn, it's okay. So, but then afterwards, I used to listen to music a lot. And one of my friends had told me that you don't have to learn it regularly. You have gone to concerts and so on. You just sing. Similarly, you imitate. And that is how I started. Then afterwards, when I was in my 40s, I started learning it ab initio, right from the beginning. In fact, I went to the teacher and then he said, where shall I start? He asked me to sing something, I sang, and then he said, where shall I start? Then I said, from Swaras. You start from Sarali Varishai, it was called. From that you start. He was amused. He taught for 2 or 3 months those basic things. And then slowly, so I learned from him regularly. He was one of the great teachers, I would say.
Where was this?
Shanmukhananda.
You have written, how many books have you written?
Only 2.
Only 2.
One on global calculus by myself, and there was an Abelian varieties with another fellow, Allan Adler. And
so how did these come about?
I was visiting Institute for Advanced Study, and he asked me a few questions which I answered to his satisfaction. So he said, I would like to come to Bombay. So I arranged through the School of Mathematics to have him as a visitor. And at that time we wrote most of the things. And by and large, most of the mathematics was done jointly. Some of the initial ideas there are mine, but the actual writing it up was almost entirely done by him.
How long did this take, writing that book?
It's about 2 years. About 2 years.
And the other book on global calculus?
Global calculus, after I retired from Tata Institute and went to CMI, that is when I wrote that book. And it didn't take too long, maybe 6 months. And I was also asked to write some more books by the same, so that means that they must have had a good reception from American Mathematical Society. So they asked me to write, and I started writing algebraic geometry. And that is still some 2 or 3 chapters I have written. It remains there. My daughter, who is also a mathematician, keeps saying, why don't you write that book? Why don't you write that?
So, your experiences as faculty at TIFR, would you like to say something about how you interacted with students, how many students you have had?
The only thing I would like to say is that we were too rigid. I think mathematicians at all levels, above a certain level, I will say, had to be encouraged. Somehow, we put the scale a little too high, I think. And that was not very good for the school. After all, even in good places like Harvard or Princeton and so on, all mathematicians are not at the same level. And of course, one of the reasons they say we decided was Baba and Chandrasekharan's idea that Tata Institute should be like Institute for Advanced Study, not involved in teaching, concentrating on research. I think that was not a great idea, particularly from a country like India. So we should have engaged in teaching a lot, to a large extent, teaching graduates, at least graduate teaching. I involved myself as much as possible. So, because I felt teaching was very important. I said that if people like Bott and Borel are teaching undergraduates, why should we not engage in teaching?
Borel wasn't teaching undergraduates.
Borel was.
Athiya probably was teaching.
Athiya was teaching.
So you had interactions with V.S. Varadarajan.
Yes.
I mean, how close were you? Not particularly.
Not mathematically, but personally we were very close.
Of course, K.R. Parthasarathy was also close to you.
Personally very close to K.R. Parthasarathy, because I knew the family also.
From your college days?
From my college days, we used to, my honors thing, neither of us were affluent, as I explained to you, particularly during my honors course. And we used to learn by writing the problems on the floor with chalk piece, so that you don't have to buy notebooks. You can save on that. And even when I bought a rough notebook, I would first write in pencils and then write with ballpoint pens on that, so that I can use the same rough notebook twice.
You didn't erase what you wrote in pencil and use it again.
This book, Global Calculus, can you explain what the book is about?
Global calculus is, after all, there is differential calculus, which is done. Even we learnt differential calculus properly for R and even for C and so on, reals and complexes and so on. But if this has to be done, let us say on the sphere, it was actually some of the calculus was done also in complex geometry to extend it from C to P1 occasionally. And I thought the right way to do it is do it locally, and then if it is done properly, you extend it to the whole variety. So that was my understanding of calculus, which is globalized. So in the global calculus, I have done elliptic operators, this, that, and so on and so forth, differential geometry, everything globally. But in fact, people even used to say, you do shift theory first and then, and some people will say algebraic geometry wise, you do differential geometry. Because to go from global to from local to the global, you do the transformation of coordinates and so on. I didn't want to do that. I wanted to do it by shift theory globally, so that later, even Durham's theorem and so on and so forth, all of them will come naturally, rather than again starting from the finish, from the beginning. So that's how it was done. And only one remark, Mumford once said, you called it global calculus, so it will sell. So I didn't know it was a joke or it was meant. So
No, I think Spivak has a book which he calls Calculus on Manifolds.
Yeah, Spivak.
I see.
Yeah,
There's a several volume.
Spivak, small book.
No, there's several
There's a
volumes.
bigger book, more recent. Yeah, Calculus on Manifold was a small book, and the
What he does is Calculus on Manifolds in that book, without question.
Spivak's book. Yeah.
But does he use sheaf theory to
No.
patch?
No.
That is what I'm saying.
I mean, it's
That is what's new.
maybe one can call it differential geometry in growth and decay in spirit.
Yes, correct.
Yeah.
That is why I said, one of my students, Nitsure, said it is algebraic differential geometry. So I even wondered after he said that whether it will have number theoretic consequences, some of the theorems. Particularly connection, whether number theorists have any use for a connection. It will be interesting to know. I have not kept up with the literature. Whether anybody has looked at it, I don't know. I must say, after I went to Chennai, I was involved in teaching for 15 years or more, 20 years. And I could influence many people there, both PhD students and undergraduates and so on. And in fact, one of those girls who was doing PhD, who did PhD later, and we were sitting at a dinner, and some other girl who had come from elsewhere asked, "Is he your mentor?" Because we were sitting at the same table. Then she said, "No, he is not my mentor. He is a universal mentor." Because I used to go to students and say, "What are you doing?" And then I'll help them.
You also taught abroad, right? Harvard, etc. How are the students compared to students in India? How do they react differently?
I was only teaching undergraduates mostly there when I went there. And except for collaboration. That's a different thing.
Right, yes.
And so I don't have much input. But one thing I would say, in UCLA, for example, that was one of the places where I stayed a whole year and teaching. And I was also involved in seminars and so on, which was well received. But the students, I found, in UCLA at least, the Iranian students were brighter than the American students who were there. So I mentioned it to somebody later, and then he said, "Yes, you got it right." So I don't know whether it is still true.
As late as recently as 10 years ago, Mariam got the Fields Medal.
She got the Fields Medal.
So it looks like Iran is keeping up.
Yeah.
Undergraduate students, did they come and talk to you in America?
Occasionally, yes. Yes.
In India,
they do.
They generally do.
They do. But you must also say, there is a tuition hour, which is mandatory.
Oh, tuition, yeah.
So you say, "I am available from such and such a date on Fridays and Tuesdays or something."
Right. And they do
come and discuss with you. And it is not, so you cannot say students come and discuss with you, because it is done, it is mandatory. And but one of the things I learned is quiz and other, how to conduct examinations and so on and so forth, which was very useful when I began teaching in CMI. I was the only one who was using those methods in CMI. I will announce, as American lecturers do, on the first day, this is how I am going to organize my undergraduate lecture this semester. There will be 3 quizzes and there will be 2 undergraduate lectures and then 1 final lecture, and these are the marks that are given to this and so on. So in spite of all the influence in any university, this is followed yet. In Bombay University, is it done? No. And surprisingly, students like it very much. They keep saying Ramanan does this and so on and so forth. It is. I was very pleased, more than any graduate achievement. Undergraduates appreciating your teaching. This was also very good in Tata Institute. In America, if you have a mentor, then you discuss only with him or his students. In Tata Institute, you just walked into any room, and if they are free, you begin discussing with anybody.
Very often you did it in the canteen.
I think that is great. I hope that continues.
He was asking you about being on the faculty at TIFR. So,
yes.
How did the faculty take decisions? TIFR faculty. If you want to understand TIFR through Ramanan.
I don't know. By and large,
was it a discussion?
As I told you, one problem was that I am also responsible. I am not saying others were like this. Setting the goal high. We did not have the experience to keep it at a high level, but not too much, too high. So I think that was a fault.
And well, I think I would put it like this. We are somewhat like nouveau riche. Like the nouveau riche.
Oh, nouveau riche.
How we are behaved.
Correct. We didn't have the experience. I don't mean personal experience. Everybody has only one experience or 2 experiences in 2 places. But I don't mean that. I mean a cumulative experience.
TIFR achievements are all very recent.
Yes. So we did not.
With not more than 25 years old when we were on the faculty.
Yes. And also for that reason, we did not go to the universities and teach at various levels and so on. But I would say K. Chandrasekharan tried his best. He also arranged summer schools to which he invited. And for example, I would give one example of inexperience. The first summer school was on topology. That was not the first pamphlet published, but that was the first summer school. And Casey asked me and Narasimhan to run that school. Okay? Then it was on topology.
Algebraic.
So we arranged, we said, what will you do here? You will keep asking for a few days. Then we will say we will do algebraic topology, we will do singular homology, this, that, and so on and so forth. And then one day he said, it was maybe called algebraic topology, I don't know. Then he said, we call that name so that people will come. They do not know any basics. You should start with set topology. I cannot say, I will teach you set topology, they will not come. They will say, do I not know set topology? But you have to tell them that, and then finally, as a sort of a general thing, you should do this. You should not impose it on them. This is not meant to bring research to them.
Can you say something about the students you have had?
Yes, I was very lucky with the students I had. And once there was an occasion in the Madras University where the ex-chief of DA, Chidambaram, was the chairman. And he asked me a few questions, and then publicly. And then I said, more than any awards which I might have got, what pleases me very much, because he said something about Bhatnagar Award and so on. But what pleases me most is five of my students got Bhatnagar Award. That makes me proud rather than what I got. And then he said, afterwards when he spoke, he said, I did not expect anybody to say this and so on and so forth. So that's an answer to your question.
So there were, I guess, Raghunathan, Patodi, Ramanathan.
Patodi, Ramanathan, Shravan Kumar. I don't want to miss anybody.
Yeah, that's why.
You're saying all the students? Usha.
Usha, okay.
Mohan? Mohan was...
Mohan officially.
Kumar.
Kapil?
And
Kapil, you
Kapil and Jaya.
Jaya.
And
Indranil.
Indranil.
Oh, very good.
Well, technically, Patodi was not your student, right? Technically.
He was technically Narasimhan student. But he actually said, I am a student of both.
Yeah, and Raghunathan also. Yes.
Yeah.
Raghunathan also.
I was also not technically a student. But I learned a lot of mathematics from him. Actually, that way, of course, apart from, in fact, I probably learned more mathematics from Ramanan than from Narasimhan. My early interest was in algebraic topology, and at that time, you were the only one who was knowledgeable in algebraic topology at the Tata Institute. And I learned a lot from you, and learned something of Lie groups also from you. Sophistry seminar, you suggested it to me. And
Naturally.
that was my Bible.
Yeah. Is it possible to put your mathematics for a layman? Is it too complicated?
It is too complicated.
What's your estimate of mathematics in India today?
I think mathematical research has spread better now. It was confined to some 1 or 2 or 3 places in those days, and the two in 1 or 2 subjects. And now it is prevalent in more places, and I do not know what is the level at which it is done right now. I suppose it is as good as it was before.
Government awards for mathematics and science in general. Do you think, what do you think of them? Like the Bhatnagar Award, should it be given?
Should it be given?
Yeah. Does it make sense?
No, Bhatnagar Award is good enough.
Or should there be more awards? For example, at various levels. Bhatnagar Award is restricted to age 45. Can there be award for older people, younger people?
Yeah, that's a good suggestion. That
just after they finish their PhD.
Recognize when they are young.
Yeah.
Then it gives an incentive to work even better. And it may be, if there is in the name of Ramanujan or Harishchandra or something, if there is something to promote mathematics among young people, it will be nice.
Yeah, purely aesthetics. Aesthetics of mathematics. When you say it was a strong, powerful theorem, or when you say it's a beautiful theorem, what is the difference?
Yes, I often say, apart from this, I want to say, one of the main characters of mathematics is that it's permanent. For example, Euclid said there are infinitely many primes.
Oh, yeah.
And he took, say, there are only finitely many primes, take the primes product and add one.
Yeah.
Now it is not divisible any one of them. Therefore, there must be another prime.
Right.
And today also, we teach the same thing with the same proof. So, once something is proved, it is permanent. Whether it is permanently useful is another thing.
Yeah.
But if it is proved, it is proved.
Yeah.
So that you cannot say about other scientific subjects because new experiments may disprove the whole thing or add to something and so on and so forth. But there is no permanence.
Yeah.
So
Is that?
that is one of the characteristics of mathematics.
Yeah. What's beautiful there?
It is beautiful. But beauty is in the eye of the beholder. So it depends.
So, what you consider beautiful may not be.
After all, Einstein's theory is beautiful for a physicist, right? So,
Yeah.
so it is not as if beauty is a special characteristic of mathematics. Most of scientific subjects, of course, not to talk about art. It's all beauty is important.
Is mathematics more art than science?
More?
Art than science?
Yes, I think so. It belongs more to art. Yes. But I must also say that Narasimhan and I did something long ago, and it was very soon. Not merely that, there is something in connected with Moduli of vector bundles. Physicists found use for it. And similarly, we did something universal connections and so on. And then gauge theorists began using it. And Simon Donaldson started using it. Mathematics is on the boundary. Others may use it. But we, pure mathematicians at least, do it for the beauty of it.
Is there any one mathematician of all time whom you admire and through the millennia? I mean, you'll be admiring many people, no doubt, but is there one single person to isolate whom you admire more than anybody else?
I don't know, for just the beauty of things, I would say I admire Hopf.
Hopf.
Yes. And he has done a lot of work with, say, Samuelson and so on, others. But his writing is also beautiful and it remains the same over a period of time. So, since you ask Hopf, Stiefel, that Swiss group at that time.
So, you're not talking about moderns. You're talking about relatively modern people.
Right. Yeah.
Yes.
So, are there?
Oh, you are talking about.
Over the ages, is there anyone you admire?
I don't know about ancient mathematics sufficiently to.
Not ancient. I mean, for instance, Raghavan and Narasimhan would say Riemann all the time. It was clear that he probably placed Riemann above anybody else in his perception. That kind of thing do you have? You may not have it, so there's no need to have one.
I liked Klein. In fact, in volume 2 of Mathematician Allan, he wrote a paper which was very useful to us doing genus 2 hyperelliptic curves to determine the vector bundles moduli. And I loved that paper. Mathematician Allan, volume 2.
What are the awards you got? And is there something special among them?
Not a great lot, but I got the Bhatnagar Award. I got the Srinivas Ramanujan Bicentenary Award. And then I got the Third World Award. I am quite pleased, and I am not particularly avaricious to get more awards or something.
Yes, exactly. Yeah,
so
sure.
I'm quite satisfied.
Purely outside mathematics, are there men or women whom you admire for whatever reasons? Non-mathematicians.
Non-mathematicians.
You can't think of anybody.
Lots of them actually.
I mean, not necessarily living.
Yeah. For example, Shamangudi Srinivas Iyer.
Yeah, in case, yeah.
He was a great musician. So, from music subjects.
Politically, political people.
Political
Politicians.
people, should I say it? I don't know. But I am an admirer of Nehru. Because whatever the political views, economic views, etc., he was instrumental in all the, including these IIT, I suppose, I don't know, in the creation of IITs, in the creation of Lalit Kala Academy, Sahitya Academy, and things like that, anything which is...
And your alma mater, TIFR.
And TIFR, Statistical Institute. After he became the Prime Minister, he did all this, and I do admire it.
I suppose you also admire him as a writer. As a writer.
As a writer,
Oh, yeah.
I have read the autobiography. I have read This Girl from India.
I had, with this context, I had a conversation with Chandrasekharan, long time ago, K. Chandrasekharan. He told me there are only three people whom he admired. Homi Bhabha, Jawaharlal Nehru, and Harish Chandra.
And?
Harish Chandra. He said that. Do you have any message for students?
Young
Students
people.
in these days?
No, nothing in particular, except I do not consider myself eminent enough to give a message to the students. But I suppose, regardless of what your degree or whatever will bring you, if financially or economically, you should go by what interests you. That is what I would say. That I have implemented in my family. My two children took up whatever they liked. And if they chose something and they didn't like it, they were free to choose something else. So it is not, you see, in our days, for example, regardless of your interests, if you are a bright kid, you go to engineering. If you are not that kid, go to medical. Like this, there was a hierarchy. I don't think that's good. You should take up what interests you. If that's a message, yes.